Hey everyone, good morning, good afternoon, good evening to all of you from all across the world. Drop a comment here, let me know where you are. I am coming at you from the United States in Kentucky, so right in the heartland of the country, but love to know where you're tuning in from. Today we have an awesome workshop with Hubert from the MongoDB DevRel team. He's going to be walking through all things RAG with you. If you don't yet know what those three little letters mean, no worries at all. That is exactly why you're here. You're going to get to learn about some of the coolest things on the cutting edge of AI. And next time you go to a hackathon or work on a personal project or go to that internship or job, you'll have some really cool skills to take along with you. So let's welcome Hubert to the stage. It is his show now, and he's got some awesome content for you all. Hey, Hubert.
Hey, thank you very much for the introduction. Hi, everyone. I see we have some folks from India or Indian from the US. Hey, hi from Morocco. How are you? Cool. So welcome to the session. Today we're going to talk about retrieval-augmented generation or RAG, and that's going to include chunking, embedding, and semantic search. Um, You'll gain like some hands-on experience at the end of this workshop. Typically, this is like a 2-hour session, but since today we're on video and we have about an hour, I'll go a little faster than usual. So normally we stop for like 15, 20 minutes to let everyone do the exercise, but with the magic of video, you can pause and do it on at your own pace and then resume later on if you want. You'll have access to the slides, and the workshop itself is gonna stay online for a long time. So don't worry if you're not like in step lock with me. And with that, let's tell you a little bit about who you're watching. So my name is Hubert Noen. I'm a lead developer advocate at MongoDB. I joined about 2.5 years ago. I'm based in Miami, and part of my job is to run those workshops. And we do the same ones in person as well. It's a very different environment. You should try someday. Um, I don't come from the database world, even though I did work with a lot of data. I'm a former video game programmer and graphics engineer. And you can see some of my work in the GPU Gems 3 book that's still selling on Amazon. So it's really a pleasure to be here today. And with that, let's move on. Okay, I'm looking at the comments just a little bit. Yeah, that's great. We have a lot of attendees. Okay, so today you will have the opportunity to earn one of the MongoDB skill badges. I believe we have about 9 or so. And today, at the end of the session, you'll have enough knowledge to earn the RAG with MongoDB. And the skill check is 10 questions. You need 8 out of 10 to earn the badge, right? So once you have it, you can share it on your LinkedIn. It's great. It shows that you are interested in cutting edge technologies, and you can even ask for a raise, maybe. So you can try that. Okay, so today we're going to go through the lab setup. All right, so I'll show you how to set up the lab. It takes about 5 minutes. We're going to run a containerized virtual machine, and we're going to set it up. And while it builds in the background, we can go back to the slides and kind of talk about what RAG is, what use cases it can be used in, what are the different components of RAG, and then we'll build a RAG application, at least the backend side of it. That's the one that touches the database. And then hopefully we'll have time for Q&A. And with that, let me explain some of the emoticons that we're going to use in the instructions. So I'm not sure where we're going to share the slides, but someone from Major League Hacking can probably answer that. So in the instructions, you're going to see different emoticons. The hands, show that you need to take some kind of an action, right? Because it's a hands-on workshop, you'll be expected to take action, do some exercise, add some code, things like that. We have the superhero character here, and that means it's an optional part of the workshop. So if you have extra time and if you want to dive a little bit deeper, these are optional, but awesome to do. When looking at the code, you'll see these placeholders with code block and then some number. That means you either have to implement the code yourself or you have to go back to the instructions to look at the answers if you run out of time. And then if you have the book emoticon, it means it's just information that you should know or in order to do the exercise. So a lot of it I will talk about, but if you are doing it at your own pace at home, there's a little bit more information that you can use to dive deeper in there. Okay, so let's do the setup. And for that, we're going to go to this address. And I'm just going to open it in a new tab. But for those who are watching the video even later, you can pause, type the URL, and then you'll end up on the landing page like this. And then click on the Start Lab button. And the first part of the lab is going to be here, Setup Dev Environment. And so the general principle with this set of instruction is every time you're going to scroll down, follow the instructions, and then at the end, go to the next phase. Okay, so here we're going to use option 1, GitHub Code Spaces. It's super convenient. It's going to launch a virtual machine with everything you need inside, including a Jupyter Python notebook and a MongoDB database in the same container. So navigate to this link here. So I'll open it in a new tab. And so I did a trial earlier, so I could resume that code space that I had, that virtual machine, or I will create a new one to kind of show you what it looks like when you're creating a new one. Okay, so all right, so when you launch it, it's going to set up like a Visual Studio looking environment, and it's going to load all the components needed. And that's going to take about 5 or more minutes. So in the meantime, let's go back to the slides. And let's talk about what we're going to build today. So in many apps, in most apps that have a user-facing interface, you have a search button, right? So you have something like this. And more now, you're going to have the ask, the AI button. And that will trigger a smart chat, like a generative AI interactive chat. So you're going to see that more and more. And today, we're going to work on creating the backend of one of those chats. So if you go to this URL up here, you can actually try it for yourself if you want. It's a chatbot that we have created that basically answers questions about how to use MongoDB using the MongoDB documentation as the source of information. So to do that, the bot is going to retrieve some parts of the MongoDB documentation and then formulate an answer. And that's why it's using RAG, right? So it retrieves documents from the MongoDB doc and then uses it to generate an answer to the user. Right, so it looks like this. And if you're not familiar with the MongoDB syntax, for example, that can save you a ton of time. Okay, so what is RAG? All right, so maybe in the chat, if you've heard of RAG or if you've used RAG, put an answer, send us a little message so I have some idea of like who knows about RAG or not. It's always fun. So it's a not a completely new concept, but it's making more and more noise in the industry. So RAG stands for Retrieval-Augmented Generation. And that's a technique that's used to enhance the quality of LLM answers, right? Because we can use information retrieved from external sources to the LLM to feed extra context so the answers have the precise information you're looking for. So there's three main ways to interact with LLMs today. You could do simple prompting, you can use RAG, or you can use AI agents. So let's take a quick look at each of these cases, and we'll build an intuition for when to use RAG and when to use the others. So with simple prompting, you're basically asking the LLM questions and expecting the LLM to reply with its parametric knowledge, or the knowledge that it is built in, that it has built in, that it was trained with. But it means the LLM cannot answer questions if the information is not present in the trained set of knowledge. Right? So for example, if you have private information or confidential type information, or just information that's not very well known, then the LLM most likely is not going to be able to reply with precision. So now if you used RAG, right? So if you use Retrieval-Augmented Generation, you have the opportunity to bring information to the LLM. So now the LLM has access to the right info. So for example, if I ask, what's the PTO policy of my particular company, I provide it, the LLM now has the right info, it can answer, but it can still not handle very complex tasks that maybe requires multiple steps. If we add some sort of memory, RAG can provide some level of personalized answers, right? So if, for example, I interact with the RAG app on a regular basis and I have an account, maybe it knows, like how I like my answers, or maybe it knows that I already asked about something previously. And we'll cover that in the workshop as well. That said, a RAG application cannot kind of self-revise and criticize or refine its own responses. You need something beyond that. And with AI agents, we're like touching the frontier of where AI is today. So with agents, LLM can reason through a problem, kind of handle problems that have multiple steps, like booking a vacation. It has also access to the right information because it's using a set of tools, and RAG is one of those tools. Finally, it can personalize responses over time because of those tools or because of different types of memories that it could use. And it could evaluate its own answers or ask like a second AI to criticize the responses that it's providing. So LLM kind of checks, agents kind of checks all the boxes. And that could be the topic of another workshop. So today we're going to stay on RAG, but I wanted to make sure that you have a broad view of what's available today in terms of AI tools. All right, so to RAG or not to RAG? As an AI developer, it's very important to be able to identify when to use which tool. So let's walk through a few examples. So if we wanted to translate hello, how are you in Spanish, do you think we should use RAG or not? I'll keep an eye on the chat. So RAG or not RAG for this one? Okay, so this is a no. And the reason why is because this type of knowledge is very well known. Yeah, Steph, exactly. And so you will very likely get the answer just using the parametric knowledge. If you were doing like a more fine-tuned translation app, then you would probably need to do something else than just the parametric knowledge. Although LLMs have been very impressive as of late, so you never know. What is the travel reimbursement policy for your org? Should we RAG that? So Guru Scott says yes, and that is correct. Yeah. So I mean, there's very little chance that an LLM would know this information for your particular organization. So it's best to provide it if you want to have better answers. So what about this one? What are some recent movies that I might like to watch? So this is a little ambiguous because it feels like there's some customization or personalization. But yes, I mean, RAG could probably do this because we want to save, like the movies that I like, and maybe the movies that I've watched recently. And so that would help the LLM to find others like it. What about that? Create a virtual travel assistant that can help me with vacation planning. And that includes, all the booking and research and all that. Is that a RAG app? Nope, that's correct. Yeah. This is way more complex than what RAG can process, right? So RAG tends to be one input, one output. And to plan a vacation, you would need to, first like look at what I like. So there's a degree of personalization. Then there's multiple actions. You might have to check if flights are available, if the hotel is available. Then you need to actually book and verify that it's booked and so on. So it's quite complex, and you would probably need an agent to do that. Okay, so here's a recap, right? So we use RAG when we need very specific information that are not going to be in the parametric knowledge of the LLM. And maybe, we need information from multiple data sources. And RAG works really well for, the questions and answers type interaction. So now let's talk about building the RAG application, and we're going to talk about the key concepts around the application architecture. So today we're going to build the backend of a RAG-based chatbot, right? And it's going to use some knowledge that we provide in terms of MongoDB documentation. And we're only going to use 20 documents to keep, the application kind of readable. But that's going to be a source of knowledge. All those documents are already in the GitHub repo, right? So we're not going to like scrape the website live. We have saved the information as JSON objects, and they will be used as is. Okay, so let's look at the architecture of a RAG application. So usually you have two main components or two main parts of the app. One is retrieval, and retrieval includes preparing the data and putting it into the database. And all the way to when you actually retrieve it using a vector search. And then there's the generation part where you were handed some very specific information and the LLM is formulating an answer. And so the retrieval part is going to use vector search, right? So the complete picture looks something like that. And let me use my mouse. Right, so the retrieval is this, right? So, oops, let me go back. Documents, we do some chunking, we do some embedding. We're going to save some vectors in the database, and then we're ready for querying that database. And typically, you could see it as mostly like a one-time process. Obviously, if the data changes, you'll have to go through that step again. But then every time a user comes and asks a question, then we're going to fetch some knowledge from the database and then the LLM. So here we have Amazon, but we're open to any LLM. The LLM is going to create an answer and then send that back to the user who might maybe have a follow-up question. So that's the general flow. So we prepare the data once, and then every time the data changes, we'll update it. And then many times, we're just going to provide answers. So when we're talking about retrieval, those are the three steps that we need to perform. Chunking, and we're going to go over all of those: chunking, embedding, and then using the vector search for retrieval. Let's start with chunking. Let's say your documents, right? So we are looking at the MongoDB documentation, and if you go on one of these pages, they tend to be quite long. And what we're going to do is we're going to split that information into smaller chunks. And each chunk, hopefully, will have a specific topic, right? So we don't want to diffuse the topic of a document too much because it makes it harder to find it later. So we're going to split a document in a bunch of little chunks. And then for every chunk, we're going to save it into the vector database. There's different ways of chunking your data. And so, for example, here we have 3 methods. The one at the top, the fixed token, is kind of like the most trivial one. But you can see here, maybe it's going to split the data in the middle of the sentence or even in the middle of a word. So you might lose kind of like some of the meaning of your data. And a different strategy is to do a recursive. So we're going to try to see where like the sentences are being split. So we can use, some special characters as chunking delimiters if you want. And then usually you would get a little bit better results. And then we also have the notion of overlap. So at the end of one chunk, we'll kind of fetch the beginning of the next chunk. So we have some overlap. And with that, we are hoping to preserve as much semantic as possible. And that's what we're going to do today. And then finally, if you have a way to find or to refine the semantic meaning of a particular chunk, that's probably the best way to do it. So all the semantic meaning is preserved into a chunk. Right. So if you have questions about chunk, let me know in the chat. But for now, I don't see any. So let me go back to the slides. Yeah. Okay, so if you want to know more about chunking, there are a lot of ways to chunk your data. And here we're just going to scratch the surface and introduce the concept. But one of my colleagues wrote a great series about AI, and this is one of the kind of fundamental piece. How do you want to chunk your data? What are your options? What strategies should you use? Read that, and it's going to save you a ton of time. You'll have a good starting point for your app. Okay, so here you can see like a MongoDB query using our query API. So it looks like that if you're not familiar with how MongoDB queries work. But most people would rather not use the query language and then use natural language. It makes a lot of sense. And to do that, you need a way to retrieve data or to query data based on natural language. And that's why we're using vector search, and vector search uses embeddings. So in the previous session with Major League Hacking, we explained how vector search works. So hopefully you can go and watch that episode or that session, and hopefully we can have the link in the chat as well. But just in case you haven't been into that session, I'll go quickly over what vectors and embeddings are. So embeddings and vectors are the same thing. So embeddings are a special type of vector that are used in the context of semantic search. And a vector, you can think of it as, like I think everyone is familiar with 2D vectors or 3D vectors, where like X, Y, Z. Vectors kind of represent a location in a multidimensional space. And the coordinates, so where you are in that multidimensional space, is derived from the semantic qualities of the data. So here we have an example where the white square is the vector space. And you have dog and cats. They're both animals. They have a similar semantic, right? So that's their similarity. They're both animals, or maybe they have both like 4 legs. They are in some corner of the vector space. And you have apple and oranges. They are fruits. They are very different from the dog and the cat. And so they are located in a different region of space, right? So depending on the meaning or the similarity of your data, they will be stored in different location in that vector space. And the reason why we use vectors is because we can use the geometric relationship between different coordinates to find things that are similar to others. So I think the easy way to think about it is in terms of distance. It's not the only way to compute the relationship, but you can think similar things are close to each other in that vector space, right? And the embeddings are the coordinates in that vector space. All right, so now we know what vectors and vector embeddings are. How do you create it? Well, the good news is you typically don't have to create those. I mean, they are being generated by an embedding model that someone else has already built. And there's literally hundreds, if not thousands of them out there. Each embedding model aims to create some type of similarity among the incoming data, right? So generally speaking, they work this way. Some data comes into the embedding model, and it could be, think of it as an API request, for example, right? So you send your data. It could be text, audio, photos, anything that's embeddable. And then the embedding model is going to, work out how to organize that data in space, and it's going to return you a vector or an embedding that's the coordinates in that vector space, right? So all you need to do as a developer usually is to choose an embedding model and then send your data to it, get the vector back for your app. Okay, so now we want to create those vectors for every chunk we have, right? So we have those big documents, those big pages of documentation. We split them in a number of smaller chunks. And for every chunk, we want some coordinates in the vector space. So you have your document, you split it in some number of chunks, and every chunk is going to be sent to the embedding model. And then we'll have some vectors back, and we can save both the chunks and the vectors in the database. So here, MongoDB. And here's what it looks like. So I'm not sure if you've used MongoDB before, but it's a document database. So a document is similar to a row in a SQL database, right? So a document would look like this, right? So we have some information about like some stock ticker, and then it looks like it's like the transcript of some event. We're going to split this document into multiple subchunks. So every of those documents are smaller than the original. And here you can see the embedding, and it's a vector, right? So a vector is an array of floats, right? So if you had a 3D vector, you would only have 3 dimensions, 2D vector, 2 dimensions. Here we're dealing with vectors that have hundreds of dimensions. You don't have to call it embedding. You can call it whatever you want. Okay. And today you have multiple, systems or tools that are required to build all of that. But the good news is MongoDB has acquired Voyage AI not so long ago. It's a startup. And in the future, we're going to integrate all these different pieces. And hopefully the idea is that very soon you'll be able to point MongoDB to your data, and Voyage AI will do the rest for you. It's going to generate the embedding models and kind of save them and all that on your behalf. So it's going to get even easier. Now, the next question we usually get is, okay, I know what an embedding model is, but how do I choose the embedding model? All right, so we have this article for you. It's going to save you a ton of time as well. It's going to give you a great overview, and then you can get started on your app as soon as possible. Okay, so by now our environment should be up and running, and I'll show you how to use the lab, generally speaking. So even if we don't have time to do all the exercises, you'll get the gist of it. And it takes about a half an hour, 45 minutes to do on your own. And then you'll have ample time. You can go back to this video later. So we are here. So in the instructions, right? So we're here. And then we're going to the code space. And we look at the notebooks. The one we're working on today is the RAG lab. So the way it works is it's a notebook. So if you haven't used this before, a notebook is a mix of MD, so like a text, and then you have code blocks that you can run. Before running any code block, you need to select a kernel, and we're going to pick a Python environment, and the one you need is the one based on Conda env. Okay. All right, and then from there, every block where you have code is expected to be run at least twice, because sometimes we do have definitions, and sometimes, for example, here we are importing some libraries we're going to need. And then here we're kind of initializing some definitions and variables that we're going to use later. And note, we have this URI, which is your MongoDB database. And that's the one that is running in this virtual machine right now. So if you need to visualize your data, you can go to the MongoDB plugin extension here and add the connection. Okay, connect. Just paste that connection string. You don't need the user pass. And then now you're connected. You can see here some kind of out-of-the-box databases. Okay, so let's go back to our code. So we've executed this. The cluster is online. Everybody's fine. And then now we're going to do more setup. Here we have this serverless URL. So that's an API endpoint that we've created and we're hosting on your behalf, so that you don't have to worry about getting a token for your LLM and embedding models. All right, so we're going to download the data set. And you can see everything is taking some time to execute, but you have some visual feedback. And now let's look at how many documents we have. We have 20 documents. And if you're curious, the docs are actually here, right? So you can open that JSON file and see the data. And we'll preview one here. Okay, so that's like a JSON object. And docs here is in a memory, right? So it's an array of docs in memory. Okay, so we've done all the setup at that point. And actually, if you go back to the exercise, you'll see we need to, so we've done this, download the data set. Now we're going to chunk up the data, generate the embeddings, and then save into MongoDB. All right, so we're here. So chunk up the data. All right, you can execute that. We're going to chunk based on some separators as well. And we're going to use this LangChain function. So LangChain is a framework to help with AI applications. So they have a framework for RAG applications, and they have a framework for agents application as well. So we're going to initialize that. And then we're going to define that function that's going to basically create the chunks from a document. All right, so here you see there's a placeholder for some code. So you can choose to implement that yourself, or if you don't have time, you can go in the documentation and in prepare the data. So just go at the bottom, next, code block 1, there it is, right? So code block 1. If you can't figure it out, you can come here, do a copy, and then paste here, right? So it's up to you. I mean, Some people like copy pasting and then taking a good look at how the code is working. Some people like to kind of come up with their own implementation. So you decide. It depends on how much time you have to dedicate to this. Hopefully, plenty. So here we have the code block 2. There you go. And then, so here all right, so we went over all the docs, and then for each doc, we've created some chunks. Let's take a look at, so all the chunks are stored into split docs. Let's take a look at how many we have. So we have 107 chunks out of 20 original documents. So on average, every chunk got split up in like 5 point something. Every document got split into 5 point something chunks. And we can preview a chunk. There you go. And so normally the body of the chunk should be much smaller than the body of the original document, right? And then now that we have our chunks, we want to generate a vector for every chunk. So Steph, yes, so that's using Python because like in AI, most people use Python. There's not a JavaScript alternative to that particular workshop, but we do have examples in JavaScript. If you go to the MongoDB GitHub, you'll find some. Okay, so we're gonna generate the embeddings. First, we need to import what we need. Okay, and then we choose a model. Sure. Okay, and then now we're going to define that get embedding function, right? So get embedding is going to get like a string as an input, and it's going to go get a vector from the embedding model. So here we need that code block 3. So generate embeddings, code 3, right? It's here. It's just calling the embedding model. All right, let's execute that. So this was just the definition, right? So nothing happened yet. And then now we're actually going to use the function. And we have a loop that goes over all the chunks, right, in split doc. And then it will generate one vector or one embedding for every doc. Now we can execute. So it's going to take a little bit of time. When you work with AI, there's some latency. So RAG means Retrieval-Augmented Generation. Right? So we retrieve some data to augment the generation of the LLM when it generates the answer to the user. All right, so let's check the doc. So we still have 107 chunks. That has not changed, but now they should have embeddings. So if you go in the MongoDB database navigator, and I can refresh it, hopefully. Oh, I haven't ingested the data yet. So to do that, we need to go through this step. So let's go to block 5. Block 5 is just setting up some the MongoDB client. Block 6 is about like naming which collection we want to write to. And block 7 does actually the writing to the database. So let's do that. Block 5, so this is setting up. Block 6 also setup work.
I know Uber said he was facing some thunderstorms, so I'll check with him to see if we can get him back. Are you with us, Uber?
Yeah, I think I'm back.
Okay, you're back now. Cool.
Okay, yeah. Hang on.
No worries.
Yeah.
The thunderstorms wreaking havoc. Of course, right during the your premiere at
Yes.
the Global Hack Week.
Okay, so I'll reload the whole window. Okay, all right. Hopefully I'm back on the live again. I'm not sure if I'm back on the stream.
Yeah, I've got it pulled up. I think you're good to go. I can see the window with step one,
Okay.
with prerequisites there.
Okay, all right. Sorry, folks. I have some security software on my laptop, and then some networking thing kind of just kicked in. So let me, yeah, so we were here, and I'm going to run everything to that point. Oh no, that is this one. Yeah. Yeah, so if that happens to you, if you get disconnected and you have to like reload the whole page, you're going to lose some of the content. So you need to rerun every step from there. Right. So we're going to re-chunk up, redo all of that, generate the embeddings, and then, okay, so now it works. And we're going to set up the collection name. And so just to be sure, we're going to delete all the potential data that's in this collection. And we do that because, you know, if you run the workshop multiple times, you need to start with like a clean slate. So things have been deleted. And then block 7, now we can write to the database. And the syntax is very simple, right? So you have your collection, insert many, and then there's an array of documents, right? So if you execute that, it's going to ingest all the chunks into the database. And hopefully now I can see it, right? So if you go into the MongoDB plugin here for Visual Studio, you connect to your database, and this is the database that we've created for this lab. Okay, and then the knowledge base is here, and it contains all the chunks. And if you want to open the chunk, you can just click on it, and here's what the data looks like in the document, right? So you have a bunch of information. We sent the body to the embedding model, and the embedding model sent us a vector back that we saved. Okay. So let's go back to the slides. We've done essentially all the steps in this exercise. And so next, let's talk about the actual vector search, right? So when you do a vector search, you've seen we've created vectors for every chunk. So let's say all the green dots here, all the green items are chunks. When the user comes with a query, we're going to transform that text query using the same embedding model. We're going to create a vector. And here, the yellow dot here is the query, right? So all the green ones are chunks, but the query is here. And using vector math, we're going to find out which of the chunks are the most relevant to that query. And generally speaking, those are the closest ones to the query in the vector space, right? So that's why we use vectors, and we use that vector space. It makes it super easy or efficient to place your query into the vector space and just find what's around that topic, right? Think of your query as semantic in the vector. It has a meaning. What's the meaning around it? Okay, and now I'm going to talk about how the vector index actually works. We have a structure called Hierarchical Navigable Small World, or HNSW. And it's a way to very quickly find all the vectorized data points in a neighborhood. Right? So for example, you turn your query into a vector, so you know where it is in space, but you don't want to compute the distance with like all these points quite yet. You want to find what's in the neighborhood, but without doing any super expensive vector mathematics. And that's why we have this HNSW structure. So the way it works is it has multiple layers of connected data points. And from here, you will find one. And then from that one, you will find its neighbors. And using the multiple layers, you find more and more neighbors of the neighbors. And soon enough, you'll have the whole neighborhood on hand. And you can do that without kind of doing any like vector computation at that point. So we have a question, tokenizing and chunking. I'm not sure people would define that as being the same thing. Chunk tokens are more kind of like atomic piece of information, maybe like words. A chunk could be a paragraph. I think that would be how I think about it, right? So a token is like more like a word, and then a chunk would be more like a paragraph. Cool. So HNSWs are a really important concept to understand because at some point you'll be able to use filtering, and all the filtering or rejecting or accepting vector data points will be done during the HNSW traversal, right? So that's why you need to know about this. It's going to help you later on to optimize your queries. If you want to know more about HNSW, we have a great video that was done by one of our product manager. It goes kind of as deep as you would like to know for someone who's not actually implementing it. Okay, so I mentioned that to find like the best chunks, you need to do some vector computations, right? So now you've chosen a number of data points in the neighborhood. You want to know like which ones are the absolute best, and that's where we're going to use the expensive math. There's essentially three ways to use vector math. One is Euclidean distance, and that's pretty much like what you think of a distance between 2 points. And it works in 2D or 1000D. It's the same math concept, right? You have the dot product, and dot product is about both the angle between the two vectors, but also like the size of the vectors. So if you have one or both vectors that are quite large, then the dot product is going to be even larger. Finally, you have cosine similarity, which is more about like what angle you're going to have between two vectors. So we have a question from Steph. Is it possible to get that HNSW? Oh yes, yes. I'm sure someone can copy the link. If not, you'll have access to the slides as well. Cool. So usually you don't have to worry too much about which one to use at any given time because it's the embedding model that's going to define which one you should use, right? So whoever created the embedding model and decided how to organize the vector space is going to give you the recommendation of one of those three, ways to compute geometric relationships. So now that you understand how vector search works, let's look at how the implementation is done. You only need to do three things with MongoDB. One, generate the embedding. So we just done that in the lab. Two, create a vector search index. And then three, do the actual search query, right? So with MongoDB, you don't have to install anything else. It's kind of already in the platform. You only need to do these three very simple things. So to create a vector search index, it looks something like this. You have to define it. So that's a vector search index definition that you're looking at here. The type is vector. Path refers to the attribute name that you've decided to name your vector. It could be my embeddings or any keyword you want. And then we have these two parameters here, num dimensions and similarity. Right, so similarity refers to one of the three functions that we've just talked about. But what's num dimensions is the length of the vectors. Right? So how many dimensions you have in there, that's defined by the embedding model you choose to use. And then later on, we'll look at the type and the filters. In terms of querying, so this is a query. A query runs as an aggregation pipeline. So if you're not familiar with what an aggregation pipeline is, in MongoDB, you can have a series of transformations or queries that you apply to your data, and we call that a pipeline. You can think of it as like the Linux pipeline, right? So you have every tool, some data comes in, and what comes out of one tool becomes the input of the next tool. And the aggregation pipeline with MongoDB works in a very similar way. So for example, here you have vector search, which is the first stage or tool in the query. And it has to be the first stage of the pipeline, right? So you cannot put vector search below, down the pipe. But whatever comes out from vector search goes then to the next stage, which here is a project. So let me explain how vector search here is built. One, you need to specify an index. And that's defined by you in the code or whenever you created the index. Path, again, that's the name of the attribute in which your vector is. Filters are optional, but you can have filters if you want. Query vector. So that's the vectorized version of the user question, right? So the user asked a question, we created a vector. Oops. And then we say, we're going to pass the vector form of the query. These two are very important. So num candidates, that's the number of vector data points that you got from traversing the HNSW structure. Right? So you looked at the neighborhood, at the vector neighborhood, and you found, or you want 150 candidates, so potential good results. And then you're going to do the vector computations to actually find the top 10 that you will return. So that's the difference between num candidates. Those are in the spatial neighborhood that seem interesting. And then limit is how many search results you're going to return that have been proven to be relevant. All right. So with Atlas Vector Search, which is the cloud version of the MongoDB database, you have an integrated platform. And this is actually true for the most recent version of the community MongoDB as well. That's the one we're using in code spaces. But essentially, you have a very integrated platform that has the database, and the database has all of its normal indexes. But at the same time, you have full text search and full vector search without having anything else to install or manage. You just need to create an index and you are ready to use vector search. Vector search is not rocket science. Eventually, everyone is going to have vector search. The main difference is how easy it is to use and how more productive a platform is going to make you versus another one. That's really how I see it. Everybody is going to have this feature. The difference is how easy it is to use, and does it get in the way of you building your app? All right, so normally, in the lab, you would create the vector search and do queries and all that. But let's see, I think we have time to do that. No, we're running a little bit out of time, so I'll let you do that on your own. Now, I think you have a good idea of like how the workshop works, and with the lecture notes, you'll have all the information you need to get it done. We're at step 6 here. There's a good chunk. You have all the code here. It's very readable, very well documented. So I'm sure you'll have a very good time trying it on your own. Let's talk about the generation part, right? So we've talked about the retrieval. Now, what about the generation? So here, when the user comes, asks a question, to provide the answer, we're going to get some data from the MongoDB database. So we're going to get some chunks that are relevant to the question. And we know it's relevant because we use the vector search. And then we're going to add those chunks to the context. Right? So now the LLM has the retrieved chunks. So it has all it needs to provide the answer, and it can create an answer. It can generate an answer for the user, and the user can choose to ask another question and so on. Right. So here are different parts, right? So the system prompt are the instructions for the LLM, right? So just like you would tell ChatGPT, hey, I want you to reply to me as if you were like a nuclear scientist because I have some expertise. Or you could say, hey, I have no expertise at all. Please explain this to me as if I was like a 12-year-old, right? So this is, that's the system prompt. That's your instruction to the LLM. And then the context is the chunk or the information we got from the database, right? So here we're talking about like some financial information. And then the question from the user is, give me a summary. And then the LLM, based on all of that, is going to produce a great answer. So now what you could do is you could, in addition of doing the previous, you can add one layer, which is preserving the chat message history. And if you do that, the chat bot is going to be a little bit smarter. It's going to know more of the context of what you've discussed in the past. So for example, if in your next question, some information is implied, it is able to kind of look at the message history and figure out what you wanted to ask. And that's also part of the workshop. At the very end, you'll implement a message history system. And the final question of the workshop is, what did I just ask you? And it's going to provide you the right answer. So it's really cool. You should try it. There's a lot of LLMs out there, and sometimes it could be blocking to procrastinate, like, oh, which one should I try, right? So there's a leaderboard that shows which LLM is the best at any given time. There's a lot of benchmarking and testing that goes into this. So you can see it as a great starter point, right? But you should always build your application with the idea that eventually you'll use a different LLM. Maybe there's a better one that's coming up. You want to try it. And what's very important is in any AI application, you should have some kind of validation step in your app. And that validation step or evaluation step should tell you if what you're doing is providing the outcome or the business outcome that you want. For example, it could be as simple as asking your users to do a thumbs up or not, or to add a comment. Or maybe you can use a second LLM to gauge how good your first LLM is. So you have different ways of doing it, but you should always have some type of evaluation step in your app, just to know if like the next LLM gives you maybe 10%, maybe 5% improvement. And you should always try to gain incremental improvement to get to the next level. So you'll put the RAG application together now that you have like all the tools, you have all the data in the database, and then there's even a step where you can re-rank results, so even improve the results of the vector search. So that's in the workshop as well. And then you'll add memory. So the memory implementation here is very simple. We're keeping track of individual chat sessions, right? So for a given session, we're going to save all the interactions between the user and the LLM, or what we call that the assistant, right? So your chatbot interactions will be saved, and then they can be requeried from the database and put into the context to provide the best information possible, given everything that you've discussed with your chatbot. So it looks like that. The implementation has two functions, right? So you're going to store the chat for the user. Well, it's one function, but you store the chat for the user, and then you store the chat of the bot as well. And that's the last exercise. Okay, so by now you should have enough knowledge to do the skill check. So I'm going to ask our friend at Major League Hacking to paste the link to the skill check. It's only 10 questions. You can do it with friends. You can Google stuff online. I mean, this is not an exam. It's a fun skill check. Just to recap the session, what's the most important knowledge that you should go home or go to the office with? You know, focus on that. And then if you need to, you can do like some extra research or go back to the slide, watch the video again. You have, I think this link will be valid until like tonight at midnight. But if you get the badge, you can share it on LinkedIn. So you can use this hashtag here, and then you can show everyone that you spent a decent amount of time getting a new skill, doing the cool next thing. And with that, I wonder if you have some questions. I'll leave the QR codes up here. Thanks for pasting the link.
For anyone that has questions, feel free to drop them in the chat here. We'll pop them up on the screen for Hubert.
Typing.
They need like the little dot for when people are typing. So we don't.
That would be
I'll
nice.
I'll throw one out in case people don't have one, Hubert.
Yeah.
I'm curious, do you have any suggestions on cool things people could do with MongoDB in a hackathon setting, since many attendees here end up going to do hackathons, whether that is taking what they learned here or other stuff they might not know about that they could do with MongoDB in a place like that?
Yeah, so for hackathons, there's a lot of opportunities to build a RAG app or like an agent type app. I think the difficult part of it is to find cool data to work on, honestly, right? Because the concept, I mean, once you go to the workshop, you'll kind of master the concept, but then finding a good topic and a good data set to work on is pretty, it can be daunting. It depends like if you have a specific idea.
Cool. It looks like we do have a question here. They ask, is RAG available exclusively for MongoDB or other types of databases as well?
Yeah, so RAG should be available to any vector database that, any database that has a vector search component. So it's not something that's completely specific to MongoDB. It just happens we have an implementation or like a distribution of it that's super easy to use, right? So if you want to try and get started, it's very easy to use. And if you deploy it, it's very easy to scale as well. Sometimes, it's easy to start with something, but then it becomes really hard to scale or really expensive to scale once you're in production.
Well, Hubert, I know that we are actually past your time here, and you've been very, very generous with it. Let's do you for one final question, and then we'll wrap up.
Sure.
All right.
Okay.
We have a question here around documents. When we use documents like the FAQ of a company, does the model learn from this data or for answering through RAG applications so it doesn't risk privacy?
Okay, so I think there's two things. One, the LLM is not gonna learn from this knowledge, right? So you will have to feed the LLM constantly, right? It's not going to be integrated into the LLM's knowledge. Now, I think the question that most people ask is, hey, if I use this, LLM, would the owner of the LLM kind of send my questions back to the data center to be integrated in the knowledge later? That's more of a privacy type of issue. And I guess you'll have to ask your provider. They should have a policy that kind of details this. But if not, the alternative, if you're very worried about privacy, is to run the LLM in your own data center or your own machine. And then at that point, it's not going out.
Cool. Well, Hubert, thanks again for tuning into your first Global Hack Week with us. We certainly hope that we'll get to have you at some others in the future. Things are changing so fast in the AI space, and I'm sure MongoDB is going to have plenty of other cool features and functionality rolling out that you'll get to share with this audience. So thanks again for your time today. Everyone that was here, go get your skills badge. It's a great way to show that you know the latest and greatest skills in this space. You can also find all the info you need to do that on the Global Hack Week challenges page that you would get from the main link. Otherwise, plenty of other cool workshops and things for you all to check out this week. So go to the schedule, and hopefully that we'll see you some other workshops.
Thanks for having me. See you next time.
Thanks, Hubert. Bye, everybody.